Electricity. It powers the machinery we use and lights up our homes and workplaces. Without it, the industrial world we work in and the conveniences we enjoy at home could not exist. Because electricity is so important to our everyday lives, it is surprising that many of us know very little about it or the hazards it presents. In order to learn how to be safe around electricity, we need to understand how electricity works and what makes it so dangerous. Electricity can be confusing because there are multiple ways to measure and describe its properties. You may be familiar with the term voltage. You may have heard your car battery described as being 12 volts or your home's receptacles as being 120 volts. Voltage is a measurement of the potential difference in electric charge between 2 points in an electric field. Its unit of measure is the volt. When these 2 points are connected by a conductor, an electric current will flow from one point to the other. As voltage increases, so too does the amount of electric current, which will flow through the conductor connecting the 2 points. The flow of electrical current through a conductor is measured in amperes, more commonly known as amps. 2 points in an electric field with enough voltage to cause current flow can also be referred to as a power source. Examples of common power sources are batteries, generators, or solar panels. When a conductor is connected to both points or terminals of a power source, electric current will flow and an electric circuit has been created. It is this flow of electric current, measured in amps, which can be harnessed to do useful work by connecting the circuit to tools, motors, lights, or other devices. These types of devices, when connected to a circuit, are referred to as a load. Let's now discuss the concept of resistance. As we have learned, an electric circuit requires a conductor through which electric current flows. However, all materials do not make good conductors. Some materials are resistant to the flow of electric current. Materials that do not allow the flow of electric current are called insulators. Insulators such as plastic and rubber have very high resistance, while materials that make good conductors like copper, aluminum, and other metals have very low resistance. Resistance is measured in ohms. For a power source with a given voltage, the amount of current which will flow through an electric circuit depends on the resistance of the circuit. When resistance is low, more current will flow. When resistance is high, less current will flow. This relationship is known as Ohm's law. Electrical safety can really be reduced down to two simple safety concepts, each based on Ohm's law. One, prevent electric shock by not allowing your body to become part of an electric circuit. And two, reduce the amount of current flowing through your body should we fail at safety rule number one. In order to maintain electrical safety rule number one, not becoming part of a circuit, it's important to understand that electrical systems connect one terminal of the power source directly into the ground. This is commonly achieved by driving a grounding rod into the ground and connecting one side of the power source to it. The side of the power source connected to the ground is often called the neutral, negative, or grounded side. The ungrounded side of the power source is often called the positive, or hot side. This creates a condition which allows the electric circuit to be completed anytime a conductor, such as the human body, comes into contact with the hot conductor and the ground at the same time. In other words, if you are grounded and come into contact with a hot conductor, you will get shocked. This is the meaning behind the expression, electricity always seeks a path to ground. To avoid being shocked, you must avoid contact with the hot conductor. When using extension cords, power tools, and other devices, you are protected from contact with conductors by the rubber insulation on the power cord. Recall that insulators such as rubber have very high resistance, and Ohm's law does not allow electric current to pass through them. However, Power cords with damaged, cracked, or cut insulation may expose the copper conductors, leading to electric shock. This is why you must inspect tools, cords, and extension cords prior to use, and never use damaged electrical tools or equipment. Another good insulating material protecting you from electric shock is air. Air does a good job resisting the flow of electricity. This is why many electrical conductors suspended in the air do not have protective insulation. However, air is not a perfect insulator, and allowing a conductive object to come too close to an overhead conductor can allow electric current to flow through the air, completing the circuit and causing an electrocution. This is why you and all conductive objects you may be carrying must remain at least 10 feet away from any overhead conductors or exposed live parts. Be vigilant in checking for overhead conductors when using metal ladders, pool cleaning equipment, elevating work platforms, or other conductive objects. Another way to maintain electric safety rule number 1 is to never work on energized electrical circuits and to never attempt to perform electrical work for which you are not qualified. Here are some safety tips to keep in mind to avoid becoming part of an energized circuit. Turn off the circuit breaker powering the circuit you are working on and place a locking device on the breaker so no one inadvertently turns it back on. Remember that water conducts electricity and greatly increases the shock hazard. Never plug in cords that are wet or touch electrically powered equipment if your hands are wet. Never use aluminum or metal ladders near power lines or while performing any type of electrical work. Metal ladders are conductive and can easily lead to electric shock. Use a fiberglass ladder instead. Watches and rings are also conductive and should be removed before you work around sources of electricity. To recap electrical safety rule number 1, make sure you do not become part of the electric circuit by inspecting the insulation on cords and tools prior to use, maintaining a 10-foot distance from exposed conductors, never performing work on an energized circuit, and by not performing any electrical work for which you are not qualified. Let's now discuss electrical safety rule number 2, reducing the amount of electric shock you receive should you fail at rule number 1. You may have noticed that many power cords, but not all, have a ground prong. The ground prong is an important part of a larger system designed to protect you from electric shock. If your cord is designed to have a ground prong, it must be present and in good condition. To provide even better protection from electric shock, many power tools are double insulated. Double insulated tools protect the frame of the tool from contact with conductors by means of a special insulating system. These tools are labeled double insulated and also display this square within a square symbol. Double insulated tools do not have a grounded frame and their cords do not have ground prongs. However, the tool itself and its cord must still be inspected and verified to be in good condition before use. One of the best ways to reduce the amount of current flowing through your body during a shock event is to use a ground fault circuit interrupter. The ground fault circuit interrupter constantly compares the amount of current flowing in both the hot and neutral conductors. Any difference in these current flows represents the amount of ground fault current flowing through a shock victim's body and into the ground. When a difference of just 5 milliamps or 0.005 amps is detected, the GFCI will quickly trip, interrupting the circuit and stopping the flow of current. 5 milliamps is below the threshold for a person to feel an electric shock. In other words, the GFCI will trip before you can even perceive that a problem exists. And this is why GFCIs are so popular and required by many workplaces anytime an extension cord or corded power tool is used. In this program, we have explained how electric circuits work and the relationship between voltage, current, and resistance. We have shown how Ohm's law governs the amount of current flowing through a conductor, and how this principle is used to facilitate electrical safety through the use of insulators to prevent contact with conductors, and by using proper grounding and GFCIs to reduce current flow during a shock event. Remember, electricity always seeks a path to ground. Use the information learned in this program to make sure that you do not become part of that path. Now, go have a great day and a safe day.